We'll proceed in different coordinate system, and we will see area calculation, volume calculation as far as different coordinate system is concerned, and then we'll see interoperability if it is required. So interoperability if it is required. Otherwise otherwise we will see mainly that how we can calculate area and then volume. So that is the concept, that area and volume that we need to calculate. Okay, so vector, so nice of you, and calculus, so nice of you, algebra, so nice of you. Now, let's start with kind of through Cartesian coordinate system. Through Cartesian coordinate system, can we calculate through Cartesian coordinate system? Then can we can we calculate can we Cartesian coordinate system, can we calculate the surface area of a sphere? That is the question. Okay, only through the Cartesian coordinate system, and it's not available anywhere. You can check. So the two Cartesian coordinate, now we have seen that if I want to calculate the surface area of a sphere, if I want to calculate the surface area of a sphere, okay, so how we calculate the surface area of a sphere? Okay, so I have a a very big sphere. Okay, this is a very big sphere. Now what we require is the surface area of this big sphere. What is the surface area of this big sphere as far as Cartesian coordinate is concerned? It is difficult in a way that Cartesian coordinate, if I take x-axis, then Cartesian coordinate is in x direction, this is x direction, and this is y direction. This is fxy or z axis, z value. Now, if I take complete xy as independent component, okay, now we have seen if I have a sphere, then if this is centered at the origin, if this sphere is centered at the origin, if it is centered at the origin, then at I take any point P here, then from origin there is a radial vector, that is position vector P, that is xi plus yj plus zk. At P, what is the velocity vector in x direction and y direction? That is dp by dx and dp by dy. Now, if I have two velocity vector, if I do cross product, then it results in velocity area vector. If I calculate the magnitude of the area vector, then it is velocity area magnitude. If I integrate it along the xy plane, then it gives me area algebraic equation, area in algebra. Now that algebra, that is from the beginning of this, if I consider this as beginning, from here what is the area? If I keep changing x and y is xy plane. If I change x comma y, since this algebra, the net area of the surface I get in algebra, that is a function over x and y. So if I keep changing x and y in the xy plane, that area will keep changing. I can take two limit also as per the integration. So this is how we calculate it. Now if position vector is xi plus yj plus zk, then dp by dx is I plus dz by dxk. dp by dy is j plus dz by dyk. If this is true, then their cross product, that is a velocity area vector, is fx dz by dx, I call it fx, dz by dy, I call it fy. So minus fyi plus minus fxj plus k. If I calculate the magnitude, fx square plus fy square plus 1 square root, that is the actually velocity area magnitude. Now I have to integrate with the xy plane. xy plane. If I integrate with the xy plane, then now net integration comes as fx square plus fy square plus 1 square root dA, dA, the lower limit to higher limit. Okay, I can set lower limit as 0 and higher limit anything. Now let's proceed. What is fx? What is fxy? Function of the sphere, that is z square plus x square plus y square equal to a square. That is the radius. If that is true, then z equal to a square minus x square minus y square root. So fxy is a square minus x square minus y square root. If that is the case, then df by dx, okay, that is fx, dfxy by dx, that is fx, that comes as minus x divided by a square root of a square minus x square minus y square. Dfx by dy would come as minus y divided by square root of a square minus x square minus y square. Now fx square plus fy square plus 1 square root would come as x square divided by a square minus x square minus y square plus y square divided by a square minus x square minus y square plus 1 whole square root. That will come as a divided by a square root of a square minus x square minus y square. Now dA, where a is xy plane, so if I take dA xy plane, then it becomes dx dy. It becomes dx dy, then we will integrate first through dx. Now I have a by square root of a square minus y square minus x square dx, integration from minus a to plus a. That is the this is the sphere, then this is centered at the origin, then x-axis is like this, then minus a to plus a, minus a to plus a in y direction. This is z. If that is true, then a by a square root of a square minus y square. Let's consider that x equal to square root of a square minus y square cos theta. Then dx is equal to a square root of a square minus y square, that is constant, minus sine theta d theta. If that is true, then a by divided by a square minus y square, and x square turns up again in bracket a square minus y square and then cos square theta. That would result in square root of a square minus y square comes out, and inside that 1 minus cos square theta, that will result in sine theta. So a by square root of a square minus y square sine theta. This solution is not available anywhere else. Now in the numerator side, dx is changed to a square root of a square minus y square minus sine theta d theta. Sine theta gone. A square root of a square minus y square, a square root of a square minus y square gone. Now it came as minus a dx. That is the only thing that remained, minus a d theta. So d theta, if I integrate, then earlier it was minus a to a. If this is centered at the origin, then this is then this is y-axis. This is y-axis. This is z-axis. If my x is minus a to a, then from here it is minus pi by 2 to pi by 2. So dx minus a to a converted to minus pi by 2 to pi by 2 d theta. Theta is now pi. Okay, theta is now pi. So answer is now that minus a pi is the surface area dy. Dy is remaining. So integration of dy is y. Y is minus a to a. Y is minus a to a. Okay, if that is true, then it will result in 2a. We are getting somewhere minus, that has to be settled down by someone. Okay, so that results in kind of theta I had taken, okay, theta minus d theta. So theta minus a to plus a I have taken, that comes theta I have taken minus pi by 2 to plus pi by 2. Okay, minus pi by 2 to plus pi by 2, or if I take whatever. Okay, that is the area. Anyway, it is pi now, pi a. Now here it is 2a. This becomes 2a square pi, 2 pi a square. That is the area. That is the top of the hemisphere. That is the top of the hemisphere. If that is the case, then if I include that, it is 4 pi a square. If I had taken x equal to a sine theta instead of cos theta, then it becomes a cos theta d theta. Then nowhere it is minus. Then if I take like this, then it is like a square root of a square minus y square comes out here. And there, so x I have taken a square root of a square minus y square sine theta. So a square y that cut down, and sine theta, that is cos theta, down, and here sine theta differentiation cos theta also goes away. So it comes as a d theta from minus pi by 2 to pi by 2. Okay, then it is a pi. So it should be satisfiable. Anyway, so we calculated the surface area purely on the base of Cartesian coordinate. What about the volume? What we are, okay, so if I go with the, so anyway, this is a clean cut solution, that we have taken velocity vector in along x direction, velocity vector along y direction, and then these two velocity vector I did cross product to get the area velocity vector, and then magnitude, then integrating with the xy plane. This is what we do to get the full surface area. Okay, now if we want this surface area, then we can go with the hybrid model also. So dxy plane can, since it is a circular, if this is a sphere, if I cut down with the xy plane, if I cut down with the xy plane, then that region it cuts. If I really chop it, if I with the knife, if I chop it, then it will get a circular region. So area is actually circular region. So dy I can replace with the polar coordinate. That is, this is what we saw. R d theta dr. R d theta dr. Now we have a by square root of a square minus x square minus y square. In polar coordinate, x is r cos theta and y is r sine theta. That turns up in a by square root of a square minus r square. Okay. Now r d theta dr. So a I can take it out, and r dr divided by a square minus r square. That integration I have to calculate d theta, and then we have to double it, and we get 4 pi r. Now through a spherical coordinate, this is everything we have seen. So in a spherical coordinate, the x component is, now in a sphere, if it is a sphere, then a spherical component has three independent components. One independent component, if this is vertical, then angle from the vertical, this is called phi. Okay, and from the center of this sphere to the peripheral, if there is a line, that is the radius. So that is a, that is a, that is the radius, full radius a makes with vertical angle called phi. And if I say a sine phi, then it goes in xy plane. There it is smaller to the actual radius, that is called that radius that falls on the xy plane. That cos theta is x-axis, that sine theta is y-axis. Now x is a sine phi cos theta and a sine phi sine theta. So these are the terminology in spherical coordinate. If I want to calculate surface area, again we have the same thing, a by square root of a square minus x square minus y square d area. Now d area is nothing but the area if I cut the xy plane, that is a circular region. That area is r d theta dr. This is what we have said. So r d theta. So theta is one of the independent component. So it's all right. R d theta. Where r d theta. What is r? R is the, if this is a, then a sine phi is the r, that is in along the xy plane. We are doing fxy, whatever the algebraic function is, dA xy plane, dA converted to r d theta dr. Please refer previous videos. So r d theta dr. So r is the radius on the xy plane, but actual radius is a. So a phi, a sine phi is the r. So you can replace r d theta dr with a sine phi. R is nothing but a sine phi. A sine phi d theta dr. R again, if I replace with a sine theta, it comes as a a dr. R replaced with a sine phi. There are two angles. One is from the vertical, that is phi angle, and along the horizontal, it's make a circle that is the polar coordinate, that is theta. So the integration here is a by square root. So for a surface area, a by square root of a square minus x square minus y square dA. D area is r d theta dr. R is a sine phi and d theta, and dr. R is a sine phi again. D of a sine phi is a cos phi d phi. Now it comes as a sine phi d theta a cos phi d phi. Now here, if I see the if I see the spherical coordinate of a sphere, then that is algebraic is x square plus y square plus z square equal to a square. So if I take x coordinate, that is a sine phi cos theta, a sine phi sine theta, then x square is a square sine square phi cos square theta plus a square sine square phi plus sine square theta plus z square equal to a square. If that is true, then it is only possible if z is equal to a cos phi. So a square sine square phi cos square theta plus a square sine square phi cos sine square theta plus a square cos square phi would result in a square. Okay, if that is true, then I have now, if I set a by a square root of a square minus x square minus y square, then that would result in a, I have to take outside a cut down square root of 1 by sine square phi, that would result in cos phi. So numerator is there, here it is nothing. That side a sine phi a cos phi d theta d phi. Here it is cos phi gone. A square sine phi d theta. So a square is constant, a square I have to keep outside. This is our way, not available anywhere. So sine phi d phi. Integration is minus cos phi. Cos phi, if I calculate the hemisphere, then 0 to pi by 2. If 0 to pi by 2 is the phi, then cos phi 0 to pi by 2. Pi by 2 is 0 and 0 is 1. So that will result in minus 1. And anyway, outside there was a minus. So minus gone and there is nothing that is coming out from here. So only a square. If it is only a square, then d theta full I have to calculate, that is 0 to 2 pi. So 2 pi a square. Top hemisphere full, the surface area is 4 pi a square. So we have calculated the surface area for the Cartesian coordinate, and then through the interoperability hybrid model for the polar, and then cylindrical, then spherical coordinate system. Okay, so this is the kind of surface area. But what is the questionnaire here? The questionnaire is, we had taken surface area when we had derivative along x-axis, velocity vector, derivative along y-axis. Okay, those velocity vector we did cross product, magnitude, then integration with the area. Now the question here is, can we have velocity vector along? Now if I see the kind of surface area as far as polar coordinate Cartesian coordinate hybrid model is concerned, then surface area what we have calculated, we integrated. So now we have taken xy Cartesian coordinate only, we just substituted x with the a cos theta or a sin theta. Can we start with the, now take the cylindrical coordinate. So polar coordinate, the better equivalent is cylindrical coordinate. So if we take cylindrical coordinate kind of in a fashion, then what is the velocity vector along? There are two components here. One is r d theta, that is one component, polar, and one is dr. I mean r and r theta. R theta is one component, that is r, and radius is one component, that is r. The way we say x-axis and y-axis. So here it is r and r theta. If that is the case, then what is one velocity vector, what is another velocity vector? Calculate the cross product, get the area velocity vector, and then calculate the magnitude, and that magnitude you integrate with the xy plane, that is r d theta dr, and see if it comes as 4 pi a square. Same thing has to be done in the spherical coordinate system. Now here the variables are phi, r, phi, phi, r, that is the radius, and then theta. Okay, so if I see the three orthogonal component, then one orthogonal component, three orthogonal component. Okay, so one orthogonal component is a sine phi d theta, that is one orthogonal component. Another is dr, dr, radius can grow and shrink, dr, and one is a, okay, a, or a, okay, a sine phi d theta. A is constant, a sine phi d theta. One is dr, and one another component that it has is a d phi. Okay, a d phi. If this phi angle is there, if I have a volume has three sides. One side is a sine phi d theta. One side is dr, and one side is a d phi. So if these three are orthogonal components, then if I take only the two dimensional, like in x and y, then it is a sine phi d theta. That is the one component, and another component is a sine phi. That is the radius. Like r d theta and r d theta and dr we had taken in polar coordinate. Equivalent in a spherical coordinate is a sine phi, a sine phi d theta, and a sine phi. If these two are the components, based upon that, what would be the velocity vector? Make a cross product, get the magnitude, and then do the integration with the surface area. That is nothing but a sine phi d theta d of the a sine phi, that is dr. Okay, then do and see if it comes as 4 pi a square. Okay, so that is the scenario. Okay, so nice. So someone should calculate it. Now let's move ahead and calculate the volume of a sphere. Okay, so volume of a sphere. Now there are two ways to calculate the volume of a sphere. One is we take a small volume dV. If I have a sphere, then I take any place a small volume dV which has three sides, and that we will elongate it or maximize it for the full sphere. That is the typical, it is mentioned in the book. So dV and triple integration. So what is dV? In Cartesian coordinate, dV is dx, dy, dz. Now then integration of dx, dy, dz, then we can calculate the surface area of the kind of no volume of a sphere. Now x, y, z, x, y, and z we can take. Okay, so x is minus a to a, then this is minus a to a, and z is minus a to a. Certainly, you will not get the result. So there are some catch in the kind of, if dv is dx, dy, dz, then there is a locha in z, because z is dependent variable. It's not independent the way we are talking. So z is square root of a square minus square root of a square minus x square minus y square. That the dz, either dz has to be replaced with the square root of a square minus x square minus y square, or x and y, those are, if we are taking from minus a to a, those limit would change in terms of this limit. Then only we can calculate the volume. There is another way to calculate the volume, that is function and then surface area. if I have one independent component x-axis, if I have one independent component along x-axis and there is a function over it that is y, that is fx, and if I want to calculate the area, if it is fx, if it is fx, if it is fx, and if I want to calculate the area, there is x-axis, then fx dx, height into width, gives the area. But means integration of the fx. If I have fxy, that is surface area, and instead of x-axis I have xy plane, and I want to calculate the area, means now it will come as volume. If I want to calculate the volume, the integration of fxy and then this surface area, that is dA, that is dx dy. Same thing we will do. So fxy is the square root of a square minus x square minus y square dx dy, that is the area, and then integration will be minus a, x is minus a to a, and that is again minus a to a. What is square root of a square minus x square minus y square dx? Now if I keep a square minus x equal to square root of a square minus y square sine theta, then d theta is equal to square root of a square minus y square cos theta d theta, provided it is constant a square minus y square. If I keep it here, then square root of a square minus y square would come out, and inside it will be 1 minus sine square theta, that is cos theta. So square root of a square minus y square cos theta, again square root of a square minus y square cos theta, okay, d theta. So it will turn up as cos square theta. I don't know what is integration of cos square theta. Let's consider x equal to a square root of a square minus y square. Square root of a square minus y square cos theta, that is x. So dx is the square root of a square minus y square minus sine theta d theta. If that is true, then we have integration of fxy dx dy. Fxy is square root of a square minus y square minus x square. That will result in a square root of a square minus y square and then cos theta. I mean sine theta. The square root of 1 minus cos square theta is sine theta. And there it is minus a square root of a square minus y square sine theta d theta. Minus would come out minus a square root of a square minus y square. Again a square root of a square minus y square would turn up into a square minus y square. Minus of a square minus y square sine square theta d theta. Integration of sine square theta is theta by 2. Theta by 2 minus sine 2 theta by 4. I mean, I don't know, I have seen it. So this is the integration of sine square theta. Now we have to set from now x is minus a to a, then what about angle? I have taken as angle. So angle is minus pi by 2 to pi by 2, minus pi by 2 to pi by 2. So x is pi x by 2 minus sine 2 theta by 4. So if I take pi by 2 to sine 2 theta, then sine pi, again sine pi. So sine pi is gone. So second side gone, only x by 2 remains here. So x by 2 minus pi by 2, pi by 2. So pi by 4 plus pi by 4, pi by 2. So pi by 2 is the integration net I found in the along the x-axis. So that is pi by 2. We are calculating volume. Okay. So pi by 2. Now a square minus y square, a square minus y square dy, I have to calculate the integration. This is not available anywhere. So a square will turn up into a square y minus y to the power 3 by 3 is the integration. Now if I set minus a to a, okay, y is minus a to a. So a square y, a square y, a square y would turn up into minus a to the, if a square to a. So a to the power 3 minus a to the power 3 by 3. That would be the integration. A to the power 3 minus a to the power 3 by 3. Okay, that, okay, so that is one thing. Then if I set minus a, again minus a, then it will turn up as minus a to the power 3 and then minus again 3. So full it will become double. So now a to the power 3 minus a to the power 3 by 3 would turn up at 2a to the power 3 by 3. 2a to the power 3 by 3. Now here we had pi by 2. Pi by 2 into 2 a to the power 3 by 3. 2 gone. Okay. 2 2 okay, 2 to the power 2 pi by something like this. I'm sorry, 2a to the power 3 by 3. Now I have to double it. Minus a to a we have taken. So 4 a to the power 3 by 3 into pi by 3 pi by 2. So 2 to the 2 pi a to the power 3 by 3 is the net volume. That is for the first hemisphere, top side. 4 pi a to the power 3 by 3 is the surface volume, is the sphere volume from only Cartesian coordinate. This we have calculated. Now let's move ahead with the polar coordinate, in a sense that cylindrical coordinate, calculation of the volume. So calculation is volume is nothing but fxy d area, fxy d of the area. Okay, that is the calculation of the volume. Fxy is nothing but the height. If I have xy plane and xy is the point, then fxy is the height. Fxy is the height, that is z. Now if I want volume, then I have equation should be fxy d area, that is the volume, and double integration. Now fxy, if I see cylindrical coordinate, then consider that this is this is a cylinder. Okay, so this is like this, and there is a xy plane and it is a cylinder. So for the cylinder, okay, so if I take cylindrical coordinate, so cylindrical coordinate z is straight and there is a xy plane, but we have to calculate volume of a sphere. Volume of a sphere, if you see, the in xy plane we have the radius, xy plane we have the radius, and net area d area is r d theta dr, r d theta dr. So if for any r, okay, r will go from 0 to a. Now if I have, now this is a sphere and I am taking cylindrical coordinate, then if I make a cross section at any point, then there is again a circle. There, if I consider that there is a small r, then height is z, there is small r, and this side, this is the a, that is the radius of the sphere. Radius of the sphere in the xy plane is full a, whereas otherwhere also it is a. Now, if this is centered at the origin, if I make a cross section, then it is a circle with radius a, that is radius of the sphere. If top somewhere, if I make a cross section, then again there is a circle where the radius is anyway temporary r, it is not a, small, and there is a height z, but it forms a triangle where the hypotenuse is a. This proves that the z, that is fxy, is nothing but a square minus r square square root. This is new. It is not there anywhere in the book. All we are file disclosure. Anyway, we have one disclosure at medium.com/@ of mininc, or mininc, MINHINC, mininc.medium.com. There you can see our latest disclosure. We will file there the cosine distance formula we have proved through calculus partial derivative. That is recomputation phase, the where mean value we settle. There in the recomputation phase, what would be the actual formula that we have calculated through the partial derivative in calculus through cosine distance? That has to be watched, that has to be monitored. Anyway, now we are calculating the volume of a sphere with the spherical coordinate system. So volume is nothing but function over two independent component and then area. Area is r d theta dr, and this function, that is the vertical, is nothing but a square minus r square square root. Now we have a square root of a square minus r square, r dr, r d theta dr. Now r varies from 0 to a and theta varies from 0 to 2 pi. Then we have the first half of the hemisphere. Now someone has to calculate this. So r square root of a square minus r square dr d theta. So r square root of a square minus r square, if I do integration, it will turn up as a square minus r square to the power 3 by 2. That's why it becomes 1 by 2 where we do the differentiation. If I go for antiderivative, if it is 3 by 2, then I have to divide it by 3 and r square. So it will be minus 1 by 3 a square minus r square to the power 3 by 2. If I integrate it, differentiate it, minus 1 by 3 a square minus r square power 3 by 2. Through chain rule, it will come as 1 by 2, 3 gone, minus 1 by 2 a square minus r square to the power 1 by 2 and minus 2r. So 2 minus all gone, it will come as r square root of a square minus r square. So it will be now minus 1 by 3 a square minus r square to the power 3 by 2. Integration with dr and d theta. I mean dr first integration is over. That is the integration. Now r I have to set from 0 to a. So a square minus r square. If I set a, then it is gone. If I set 0, it is there. Now a square to the power 3 by 2 is a to the power 3. A to the power 3 divided by 3. Okay, so a to the power 3 divided by 3. That is the integration. D theta. Theta full 0 to 2 pi. So 2 pi a to the power 3 by 3 is the volume of the top hemisphere. 4 pi a to the power 3 by 3 is the volume of the sphere through cylindrical coordinate system. Okay, that nice it is. So this is our fundamental to calculate. So there are two ways to calculate the volume. One way is dv. I have not taken the other way. One is dv and then do the triple integration. Okay, and another way is that you find the function and then integrate over the area. This is our way. This is the actual integration. Now if I take cylindrical coordinates and dv dv and triple integration, if we do, then dv would result in r d theta dr dz, r d theta dr, that is the area of the kind of xy plane circular and dz. That is the dv. Any dv if I take, then integration here. But r is not 0 to a here. R and z are related to each other. So r will be 0 to square root of a square minus z square. A square minus z square. Now I have r d theta dr dz. Now r dr d theta dz. R is from 0 to square root of a square minus z square, because the radius is not everywhere same. We are taking cylindrical coordinate, but for the sphere radius is keep on decreasing. At the center here, if I make the chop at the center, then radius is a, but as radius we go top, radius is decreasing and becoming 0. So radius is variable dependent upon z. So if I cut anywhere, then the radius and z value dependent upon the hypotenuse, that is a, actual radius of the sphere. So r is nothing but a square minus z square. So integration of z 0 to a, integration of theta 0 to 2 pi, integration of r 0 to a square root of a square minus z square. Now here it is r d theta dr dz. Now if I integrate r, then r square by 2. R square by 2 and then limit from 0 to a square root of a square minus z square would result in a square minus z square by 2 d theta. So d theta will be 2 pi. So 2 gone, pi I can keep out. Now a square minus z square dz. So a square z minus z to the power 3 by 3. Variation from 0 to a. It comes to same way, that is 2 a to the power 3 by 3. So now we have 2 pi a to the power 3 by 3 top hemisphere. So the volume is 4 by 3 pi a to the power 3. So this is the volume that is calculated through what is there in the book. Take an infinitesimal small dv and then dv make a limit for bigger. Three limits are coming. Whereas actual integration is you have to have xy plane in one independent component, that is xy plane, and over xy plane we have fxy is the surface. We calculate the integration, it gives me the volume. The way if I have x-axis and if I have fx, if I calculate the integration of fx, it gives me surface area. So fx we saw that is square root of a square minus square root of a square minus z square. A square, sorry, a square minus r square, that is the z, that is fxy or f r theta whatever. A square minus r square square root. Okay, and then surface area, independent component, that is r d theta dr. Now if we integrate, we get same 4 pi a square a cube by 3. Okay, now someone has to try both way dv and this way for the spherical coordinate system. Okay, so that is the questionnaire. Another questionnaire along with the calculating the surface area in the cylindrical and spherical coordinate through the vector fundamental. Okay, so that we will see.